The installation described violates both the National Electrical Code and the Occupational Safety and Health Administration standards for temporary electrical installations. Article 90.3 of the National Electrical Code states that temporary wiring shall be permitted only during the period required by the construction process. Article 90.3b3 stipulates that temporary wiring shall be removed immediately upon completion of the construction process. Article 400.8 dictates that non-metallic raceways shall not be used or exposed to physical damage. Article 590.4 specifies that temporary wiring shall not be accessible to pedestrians or other unqualified persons. Turning to the Occupational Safety and Health Administration standards, 1910.304 states that temporary wiring shall be installed in a manner that will prevent accidental contact with water, dust, fumes, vapors, or other flammable liquids or vapors. 1910.305 mandates that temporary wiring shall be protected from physical damage. The cable supplying power to the separate structure, in place for 3 to 5 years, vastly exceeds the allowable time frame for temporary wiring. The cable lies directly on the floor or pavement without any supports or protective measures. It is susceptible to physical damage from vehicle traffic, employees, and pedestrians. This arrangement directly contravenes the National Electrical Code's regulations concerning temporary wiring and the Occupational Safety and Health Administration's guidelines for safeguarding against physical harm. Moreover, the cable's route through a metal louver vent and across the mechanical room floor introduces a potential tripping hazard and poses an electrical risk to individuals working in the vicinity. In summary, the temporary cable setup does not meet the requirements set forth by the National Electrical Code or the Occupational Safety and Health Administration. It should be promptly dismantled and replaced with a permanent wiring solution. First, consider the permissible duration of temporary wiring according to the National Electrical Code. Temporary wiring is intended for use only during construction, remodeling, or similar activities. Once the project is complete, the temporary wiring must be removed. The described installation, which has been in place for 3 to 5 years, clearly exceeds this permissible duration. This extended use transforms what was intended as a temporary solution into a permanent hazard. Second, examine the physical protection of the cable. The National Electrical Code and Occupational Safety and Health Administration standards emphasize the importance of protecting temporary wiring from physical damage. The cable lying on the floor or pavement is vulnerable to damage from vehicles, foot traffic, and other sources. This lack of protection increases the risk of electrical shock, fire, and other hazards. Third, analyze the cable's exposure to unqualified persons. The National Electrical Code requires that temporary wiring be inaccessible to pedestrians and other unqualified persons. The described installation, with the cable exposed in areas accessible to employees and pedestrians, violates this requirement. This exposure increases the risk of accidental contact with the wiring, which could result in electrical shock or other injuries. Fourth, evaluate the cable's routing through the metal louver vent and mechanical room. The cable's passage through the metal louver vent and across the mechanical room floor introduces additional hazards. The metal vent could damage the cable's insulation, increasing the risk of electrical shock. The cable lying on the floor of the mechanical room poses a tripping hazard and could be damaged by equipment or other objects. Fifth, consider the potential for environmental damage. The Occupational Safety and Health Administration standards require that temporary wiring be protected from water, dust, fumes, vapors, and other environmental factors. The described installation, with the cable exposed to the elements, is vulnerable to environmental damage. This damage could degrade the cable's insulation and increase the risk of electrical shock or fire. To ensure compliance with the National Electrical Code and Occupational Safety and Health Administration standards, several steps should be taken. First, the temporary cable should be removed immediately. Second, a permanent wiring solution should be installed. This solution should comply with all applicable codes and standards. Third, the permanent wiring should be properly protected from physical damage. This protection could include the use of conduit, cable trays, or other protective measures. Fourth, the permanent wiring should be installed by a qualified electrician. This will ensure that the installation is safe and compliant. Fifth, regular inspections of the electrical system should be conducted to identify and correct any potential hazards. These inspections should be performed by a qualified electrician. The National Electrical Code provides specific guidelines for temporary wiring installations in Article 590. This article covers the requirements for wiring methods, overcurrent protection, grounding, and other aspects of temporary electrical systems. It is essential to consult Article 590 when designing and installing temporary wiring systems to ensure compliance with the code. The Occupational Safety and Health Administration also has specific regulations for temporary electrical installations in 29 Code of Federal Regulations 1910.304 and 1910.305. These regulations cover the requirements for wiring methods, overcurrent protection, grounding, and other aspects of temporary electrical systems. It is crucial to consult these regulations when designing and installing temporary wiring systems to ensure compliance with Occupational Safety and Health Administration standards. In addition to the National Electrical Code and Occupational Safety and Health Administration standards, local codes and regulations may also apply to temporary wiring installations. It is essential to consult with the local authorities to determine the applicable requirement. The use of non-metallic cable assembly, especially without knowing its suitability for hard usage, raises concerns. Non-metallic cable such as NMB cable is typically designed for indoor use in dry locations. Its use in a potentially wet or damp environment, or where exposed to physical damage, is a violation of the National Electrical Code. Consider the following points regarding the type of cable used. Firstly, the National Electrical Code Section 334.12 outlines the use is not permitted for non-metallic sheaths cable. This section prohibits the use of NM cable in wet or damp locations, where exposed to physical damage, or where exposed to corrosive fumes or vapors. Secondly, the specific type of cable use should be identified to determine its suitability for the application. If the cable is not rated for outdoor use or direct burial, it should not be used in those environments. Thirdly, the cable should be properly supported and protected from physical damage. This can be achieved by using conduit cable trays or other protective measures. The use of a permanent structure as a power source for a temporary wiring installation raises questions about the suitability of the existing panel board and wiring. It is important to ensure that the panel board has sufficient capacity to handle the additional load imposed by the temporary wiring. The existing wiring should also be inspected to ensure that it is in good condition and properly sized for the load. Furthermore, the connection between the permanent structure and the temporary wiring should be made in a safe and compliant manner. This connection should be made by a qualified electrician. The long-term use of temporary wiring can lead to several problems. First, the wiring may become damaged or deteriorated over time. This can increase the risk of electrical shock, fire, and other hazards. Second, the wiring may not be properly grounded. This can also increase the risk of electrical shock. Third, the wiring may not be properly protected from overcurrent. This can increase the risk of fire. Fourth, the wiring may not be properly supported. This can lead to the wiring becoming damaged or disconnected. It is important to address these potential problems by removing the temporary wiring and installing a permanent wiring solution. The lack of supports for the cable is a significant safety concern. Cable should be properly supported to prevent them from sagging, becoming damaged, or creating a tripping hazard. The National Electrical Code provides specific requirements for cable supports in Article 392 for cable trays and Article 396 for messenger-supported wiring. These articles specify the types of supports that are permitted, the spacing between supports, and the methods of attachment. The cable should be supported in accordance with these requirements. The information presented underscores the critical importance of adhering to electrical safety standards and regulations. Failure to do so can result in serious injury, property damage, and even death. It is essential to prioritize electrical safety in all aspects of construction, maintenance, and operation. The use of extension cords as permanent wiring is a common but dangerous practice. Extension cords are designed for temporary use only and are not intended to be used as a substitute for permanent wiring. The National Electrical Code prohibits the use of extension cords for permanent wiring in Section 400.8. Extension cords are typically not rated for the same ampacity as permanent wiring. This can lead to the extension cord overheating and causing a fire. Extension cords are also more susceptible to damage than permanent wiring. This can increase the risk of electrical shock. If permanent wiring is needed, it should be installed by a qualified electrician. The dangers of arc flash and arc blast should not be underestimated. Arc flash is a dangerous electrical explosion that can occur when a short circuit occurs in the air. Arc blast is the pressure wave that is created by an arc flash. Arc flash and arc blast can cause serious burns, blindness, hearing loss, and even death. It is important to take precautions to prevent arc flash and arc blast. These precautions include wearing appropriate personal protective equipment, using insulated tools, and energizing equipment before working on it. Regular inspections of electrical systems are crucial for identifying and correcting potential hazards. These inspections should be performed by a qualified electrician. The inspection should include a visual inspection of the wiring, connections, and equipment. The inspection should also include testing of the electrical system to ensure that it is operating properly. Any identified hazard should be corrected immediately. Electrical safety training is essential for all employees who work with or around electricity. The training should cover the hazards of electricity, the precautions that should be taken to prevent electrical accidents, and the procedures that should be followed in the event of an electrical accident. The training should be provided by a qualified instructor. Grounding is a critical safety measure that helps to protect people from electrical shock. Grounding provides a path for fault current to flow back to the source, which causes the circuit breaker to trip and to energize the circuit. All electrical equipment should be properly grounded. The grounded system should be inspected regularly to ensure that it is in good condition. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices should be properly sized for the circuit that they are protecting. The overcurrent protection devices should be tested regularly to ensure that they are operating properly. Electrical panels should be kept clean and dry. Thus, dirt and moisture can accumulate in electrical panels and cause them to malfunction. This can increase the risk of electrical shock or fire. The electrical panel should be cleaned regularly with a vacuum cleaner or a damp cloth. The use of surge protectors can help to protect electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors should be installed on all sensitive electronic equipment. Lockout/tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. These procedures involve locking out the power source and tagging the equipment to indicate that it is being worked on. Lockout/tagout procedures should be followed whenever equipment is being worked on. The presence of damaged or frayed wiring is a serious safety hazard. Damaged or frayed wiring can expose live conductors, which can increase the risk of electrical shock. Damaged or frayed wiring should be repaired or replaced immediately. The use of electrical tape to repair damaged wiring is not a safe practice. Electrical tape is not designed to withstand the heat and stress of electrical wiring. The use of electrical tape can create a fire hazard. The best practice is to replace damaged wiring with new wiring. Avoid overloading electrical circuits. Overloading an electrical circuit can cause the wires to overheat and start a fire. The ampacity of each circuit is marked on the circuit breaker or fuse. Do not exceed the ampacity of the circuit. If you need to add more electrical devices to a circuit, have a qualified electrician install a new circuit. Be aware of the location of underground utilities before digging. Before digging, call the local utility companies to have them mark the location of underground utilities. This will help to prevent damage to the utilities, which could result in electrical shock, gas leaks, or other hazards. Use ground fault circuit interrupters in wet locations. Ground fault circuit interrupters are designed to protect people from electrical shock in wet locations. GFCIs should be installed in bathrooms, kitchens, laundry rooms, and other areas where water is present. The installation you've described, with its prolonged use of temporary wiring, the cable lying exposed on the floor, and the lack of physical protection, presents a clear violation of both National Electrical Code and Occupational Safety and Health Administration regulations. It's not merely a technicality, it's a genuine safety hazard waiting to cause an accident. The extended time frame alone flagrantly disregards the very definition of temporary as intended by these safety standards. Imagine the wear and tear on that cable over years, the potential for insulation breakdown, and the increased risk of shorts or ground faults. Then consider the physical vulnerability of the cable. Lying unprotected on the floor, it's subject to abrasion from foot traffic, crushing from vehicles, and potential damage from dropped objects. This not only increases the risk of electrical shock, but also creates a tripping hazard for anyone in the area. Furthermore, the haphazard routing of the cable through a metal louver vent and across the mechanical room floor adds insult to injury. The sharp edges of the vent could easily damage the cable's insulation, while the cable itself becomes an obstacle in an already potentially hazardous workspace. The National Electrical Code and Occupational Safety and Health Administration regulations aren't arbitrary rules. They're based on decades of experience and hard-won lessons about electrical safety. They exist to protect people and property from the very types of hazards that are present in this situation. To ignore them is to gamble with safety and to put people at unnecessary risk. The immediate removal of this temporary wiring and the installation of a permanent code-compliant solution is not just a matter of adhering to regulations, it's a matter of responsible and ethical conduct. It's about prioritizing safety and ensuring that the electrical system is designed and installed to minimize the risk of accidents. Don't cut corners or take shortcuts when it comes to electricity. It's a powerful force that demands respect and adherence to established safety standards. Anything less is simply unacceptable.